All right, we're going to be talking about basic functions and some very simple transformations of your basic functions. So this is Chapter 1, Section 3, Part B. Really, this is BC. We're going to be covering this whole worksheet in 2 days. So this first video is just on the first page, transformations. So depending on when you took Algebra 2, you have hopefully seen transformations before. I wanted to point out a couple things. In our shared drive folder, in Chapter 1, Functions and Graphs, if you scroll to the very bottom, there are a couple PDFs for your referral. This is a small, quick PDF that just one page, this one, that graphs of simple transformations summary. So we've got things called vertical shifts, horizontal shifts, reflections. About the x-axis is the one we usually use where everything gets flipped upside down, and vertical stretches or compresses. We're going to see some example of those in the worksheet we're about to work through. But if you want the details behind this document, that would have been your other, that would be this other one, Transformations of a Graph Detailed Review. This actually is coming from a textbook that I was writing, intermediate algebra textbook that I was writing a few years ago with some colleagues at my old job. And so the idea behind transformations is the following. So consider yourself standing in a room. Now imagine yourself taking one step to the right or one step to the left of your current position. Have you changed? No, it's just your position that's changed. And consequently, if you turned around and faced the opposite direction, again, would you have changed? No, just your orientation, right? Given the graph of a function, if we move its position, but otherwise keep it the same, the function equation will change, but in a predictable way, since the overall shape of the graph is the same. Such changes done to a function and its graph are called transformations. So if you want all the details about how to graph vertical and horizontal shifts, reflections, or stretches, check out this PDF. But we will also be going into slightly more advanced transformations when we get to section 6 of your textbook. So today, it's just kind of a sneak peek at some of the more simple ones, specifically the horizontal shifts and the vertical shifts and a couple stretches. So let's scroll down and zoom in. The task for each of these examples is determine the domain and range of the functions that are transformations of the basic functions. And then you can use a graph to confirm the results. So when you're doing the homework, truthfully, here's your equation. Think to yourself, I think the domain's this, and I think the range is this, and then graph it on your calculator to know that you're right. I'm going to take it the exact opposite approach. I'm going to look at this, think, and then sketch a graph of this instead of going to my graphing calculator. But for the homework, you can totally use your graphing calculator for these problems for now, because I'm going to model for you what we're going to do in section 6, basically. So let me zoom in even more. Nope, too much. Okay, a little less. This much. When I look at this first example, y equals ln of x minus 2, the basic function that this reminds me of is, so my basic function, or my parent function, is going to be y equals ln of x. And so what do we know about y equals ln of x? What is the domain of y equals ln of x? Well, what are we allowed to plug into the natural log function? Only strictly positive numbers. So the domain is x must be greater than 0. If you remember what the graph of your natural log function looks like, you have that is totally not on the same line. So pretend I drew this better. You have a vertical asymptote at x equals 0. And if you plug in 1, natural log of 1 is what? Natural log of 1 is 0, because again, natural log asks what exponent on e gives you this x value. So e to the what gives you 1, e to the 0. So this is the point 1, 0. And then, I don't know why that disappeared. And then, right, it looks like this, and you asymptotically go down. So that also means then my range of this basic function is all real numbers, right? Negative infinity up to positive infinity. That's my basic function. So what happens when I change the inside of my natural log function? When I change the inside of the function, this is called the argument of the function. So before, for my domain, let's go green. All right, when I look at y equals natural log of x minus 2, right, before for my domain, I needed x to be greater than 0. Now I need all of what's inside the natural log. I need the whole argument for the domain. I need x minus 2 to be greater than 0. I need to plug into my natural log function a positive value. And so what does that mean? Well, add 2 to both sides. X must be greater than 2. This means my domain, right? The domain is going to be 2 to infinity, right? Or x is greater than 2. You can write it either way, truthfully. So graphically, what's happening is where I used to have the vertical asymptote at x equals 0, because that was the edge of my domain. The edge, whoa, oh, I didn't even catch it. Should this be a bracket? No, it should be a parentheses, because I do not include 2 in my domain, right? Which means basically my vertical asymptote's being shifted over 2. This is the edge of my domain now. This is where the vertical asymptote is, which I should probably write on the other side because I'm going to draw my graph over here. My vertical asymptote is now x equals 2. That's the edge of my domain. This point here, 1, 0, right? When I plug 1 into the natural log function, I get 0. What x value would I need to have this argument equal 1? Well, I would need the x value 3. 1, 2, 3. And so this is the ordered pair 3, 0, because 3 minus 2 is 1. Natural log of 1 is 0. What happens? 1, 2. This point got shifted over twice. What happened to my vertical asymptote? 1, 2. It got shifted over 2. When you subtract 2 from x inside your basic function, you are shifting your whole graph 2 to the right. And so, right, this function is now going to look like this. That's the graph of my function. So my domain has changed with a horizontal shift. Horizontal, Z-O-N, zonatal, not zonatal, Z-O-N, horizontal shift, right? This is a horizontal shift to the right by 2. With that horizontal shift, your domain changes because you are changing the x values. But the range, what is the range of this guy? My range is still all real numbers, right? The y values didn't change at all. It was just the x values. So again, how would you know what the domain and the range are of this without graphing it? Well, your natural log function has a restricted domain, right? Whatever you plug into the natural log has to be greater than 0. So x minus 2 has to be greater than 0. And that's how you get your adjusted domain. How about the range? The range of your natural log function is everything. So that's not going to change because I change my x values. So those stay the same. Let's look at another example, right? Let's look at B here. Y equals 1 over x minus 4. Y equals 1 over x is our basic function, right? Y equals 1 over x is the simplest version of this guy. And again, it's my reciprocal function. So what do we remember? Right, my domain is everything except x can't be 0, right? So I have a vertical asymptote at x equals 0. And what was the range? Vertical asymptote. The range, well, 1 over x is a fraction. if I plug real values in for x, will I ever get 0? 1 divided by what is 0? Is there anything? No, right? 1 over x, so comments, 1 over x will never equal 0, so y will never equal 0. So you have this horizontal asymptote, right? You could also think of it as the end behavior. As x goes to positive infinity, this is blowing up to 1 over a million. Well, that's a really small fraction, right? And in fact, that's what helps us graph our reciprocal function, right? As x goes to infinity, I approach 0. And on the negative side, as I approach negative infinity, I'm approaching 0 negatively from below, right? So that is my reciprocal function. Now, what happens when I subtract 4 from the whole thing? Y is equal to 1 over x minus 4. Well, is that going to change the x values? Is that going to shift my graph to the right or to the left? No, nothing's happening to the x values. What's happening is to the y values. So this point right here, 1, 1, if I plug 1 in for x here, I get 1 minus 4 is negative 3. So what used to be up here goes 1, 2, 3, 4 down, right? This point here, negative 1, negative 1. If I plug negative 1 here, then I'm going to have negative 1 minus 4 is negative 5. So this point gets shifted down 4 units. Likewise, how about this vertical asymptote, x equals 0? Is that still my domain restriction? Yes, right? The domain, I should do this in green because this is for this guy. The domain stays the same, right? X has not changed. I still cannot have x equaling 0. Right? Vertical asymptote, still the same. VA x equals 0. But what has changed? Is my range, do I still have a horizontal asymptote at y equals 0? No, think about it. As I let x go to infinity, this whole piece gets so small it basically goes to 0. So negative 4 is what I'm going to be approaching. I'm going to have a horizontal asymptote now at y equals negative 4. That's my horizontal asymptote. So that tells me my range is in fact y can't equal negative 4. It's everything except negative 4. So what we see from the graph, when we graph it, is my whole reciprocal function has just been shifted down 4 units. That is what this does. This minus 4 changes the range, right? It's going to shift it down, shift down. And so in the same way that 1 over x can never equal 0, 1 over x minus 4 is never going to, well, this will never equal 0, so this will never equal negative 4. Hence our range restriction there. All right, so that's an example of a horizontal shift. This is an example of a vertical shift. You can see a few other ones that I've already worked out here. So C and D, let's just quickly talk through them. So C is your parabola. Y equals x squared is the basic function. That has a domain of all real numbers and a range of y going from 0 to infinity. When I do minus 2 here, kind of like what I did before, that's going to, again, shift my whole graph over 2. But what do you notice? There is no change in the domain, right? The domain is still all real numbers because it was all real numbers to begin with. So shifting it over doesn't change the domain, right? And the range stays the same because shifting the x values does nothing to affect the y values. For D, my square root function is the basic function here. Y equals the square root of x. Y equals the square root of x plus 4, that's going to just shift everything up 4, right? And so what changes in my original function, right, the domain and the range were both restricted. They went from 0 to infinity each, right? So here the domain stays the same, x is greater than 0, but now the range, the y values got shifted. Now y has to be greater than or equal to 4. The shift up, right, changed the range. And then quickly, your cosine. If I, again, shift it on the inside, that's not going to affect the domain. Domain is still all reals. It just moves it over 2. It's still bound by 1 and